So here's a here's the if you just go to SkyCiv, skyciv.com, you get this, and you can sign up or whatever, or log in, which is what you normally would do. But I was going to show you under pricing, they have a special one for Science Olympiad, and that's the one you would go to. We need to go to sign up, and then. But under there, you can also find some tutorials on what to do and how to build it. And I think this software can actually be used to test towers and things like that. So in the future, for the next events like towers and bridges, you could use this software. So it could be really useful.
Yeah.
Save a lot of time on, for your initial designs. But okay, so that's how you would, start an account or start an account there. But I'm just going to log in. I think it will remember my password. So I made an account. I used my name and I had made a password, and then I shared that with our kids. So they always use that. So they've been, well, I guess there's 4 design files. One of them might be one that I was working on. I don't know. Or I might have deleted it. I don't know. But they did some different design that they've been working on. I don't think they've done too much, but and I think you'll have to add in, there's a Science Olympiad app that you add in. There's some instructions on how to do it, but then you have to add this Science Olympiad app to it. But then, so anyways, what we want to do is we want to start a new, how do we start a new one? Oh yeah. Well, okay, yeah, we want to start a new one. So we want to go to that Science Olympiad app. We want to start a new file. And it will kind of remind you, it doesn't automatically save, but it will automatically remind you to save. We're going to start a brand new one. I don't need a tour. Okay, we'll open that up later. Okay, so up here, under add-ons, there's a Science Olympiad Structures app. That's an add-on, and that's what you click on to do your test. Oh, I think it's still in competition mode. Ooh, why is it still in competition mode? I don't want to be in competition mode. Why is it still in competition mode? Okay. 4 solves left. Okay, I don't know why it's not. Okay, well, we'll just pretend I don't know why it's still in competition mode, but we'll pretend it's not. I hope they submitted their results. Anyway, okay, so first off, there's the coordinate axis here. So Y is up and down. The YZ plane is the testing wall, okay? And this S1 is at position 0, 0, 0. That's what would have been the hook before on regular Boomilever. And then the S2 and S3 are the attachment points where the bottom base of the Boomilever touches the wall. And an X is the distance away from the testing wall. So you have to specify the node position. So this node position for the first one is, the nodes are where the members will join together at the node. So you define the nodes first and then add the members to connect the nodes. So you have to define it in 3-dimensional space. So this is the hook position 0, 0, 0. It's always going to be 0, 0, 0. But in this event now, these have to be can't be more than 15 centimeters below the hook, right? For division C. For division B, they can be 20 centimeters or less. So they've just set it to be 12 centimeters, but I want to go and change that to 15. So you can go to the nodes here. Oh, I should do this slower probably. So up on the left, you have all these things you can do, like the nodes, members. We don't use plates or anything like that, but so we go to nodes, and on nodes, you can either click on the node you want to look at and adjust it that way, or I think there's like a spreadsheet that you can go in and you can change. Actually, what did I do? Close. Nodes. There's a little spreadsheet thing that you can go and you can change the positions of the nodes. This is probably easier to adjust. And what I recommend is if you come up with a really good design and you have your node positions set up. Oh, well, first specify that in this event, there's two. In the regular Boomilever, nothing is varied. The dimensions are all fixed. But in the digital structures, there's two dimensions that are varied. One is the distance from the testing wall to the inside edge of the loading block. So that used to be a fixed distance before, but it's varied now. So you won't know what that is till you get to the day of the competition. And the second is the distance that these attachment points are either side of the center line going straight up and down through the hook. So right now they're saying they're 8 centimeters from the center line. One is plus 8 centimeters on the z-axis, and one is minus 8 centimeters on the z-axis from the center line that goes right through here. And then the y is now minus 0.12 meters or 12 centimeters. So again, everything's going to be in meters. So I got confused a bit, started typing in centimeters, and then distances were really long because it was thinking they were meters, but they're supposed to be. So this, we're going to change this to 0.1 minus, let's see, that's, yeah, minus 0.15 and minus 0.15. So that's going to be, oops, that's not even right. Minus 0.15. That's going to be, this part here, the y position, it's always going to be minus 0.15 usually, unless you make it a little bit less, but you can't be any more, nothing can touch the wall more than 15 centimeters below this hook. And then the z position, you usually want to make that as narrow as you can, given what they tell you. So if they say it's can only has to be at least 3 centimeters from the center line, then you would change that to 3. So let's just change that to 0.0, I don't know, 6. So 6 centimeters minus 0.06. Okay. So then let's say that the inside, that the event supervisor said the inside part of the loading block had to be 40 centimeters from the testing wall or more. So again, we're going to keep our y position at minus 0.15. And oh, the loading block is 5 centimeters wide. So that's 2.5 centimeters in positive z and 2.5 centimeters in negative z, right? So that's 0.025. And the x position for the first point, which is going to be 40 centimeters from the testing wall. So once you finish one, it starts a new one for you. We can zoom out and you should be able to see this thing. Where is it? Am I not? You can zoom out. I'm not seeing it there. Oh, because I haven't applied it yet. Okay, so let's do this again. So I got 40 centimeters away from the testing wall in the x direction, still minus 0.15. And I'm just going to do a simple design. You guys can change your design, of course, later as you practice with it. And this would be minus 0.025 meters or 2.5 centimeters going in the negative z direction. So I'm going to go ahead and apply those just to see what's going on. So here you see 0.4 and 5 out here. So the node has an ID number and then the positions here. So we're starting to see a little bit of stuff here. So let's do the other 2 points that are going to be on the corners of the loading block. So that would be, the loading block is 5 centimeters wide. So it'll be 45 centimeters then away from the testing wall, 0.45. Again, we're still at minus 15 centimeters, keeping the bottom flat. And same thing, that, and minus 0.025. Let's go ahead and apply that, and you can see, okay, so that's kind of where our loading block would be, right? And so now we need to add, now this is good enough. We can start adding members. So let's close that. You can add members, you click on members and you can actually just connect them. So we can do them one at a time, or you can define what the nodes are for the beginning and the end. So I'm just going to do the first one from node 2 to node 4. And I'll do the second one from node 3 to node 5. I'll do the third one from 4 to 6. And the fourth one from 5. Oops. Let's go back. Members. Let's see. I didn't do it, I guess. 4 to 6. Okay. And then the fourth one is from node 5 to 7. And the fifth one will be from 4 to 5. You can also move this thing around and see it in 3 dimensions. The next one's from 6 to 7. Okay, and then we got to have, so that's kind of like the base of the whole Boomilever, but we also need to have something to like hold it to the hook, right? So let's just put some beams. This isn't going to be the optimal solution, but it'll show us what we need to show. So let's put some beams from here to here, from here to here, from the hook to the farthest point then, because if we just stop there, it would, the end would just break off, right? So we got to hold the end point too. And okay, so we got that. So that's pretty much all we need to, at this point. I mean, I'm not going to do any braces or anything like that. I'm just going to leave it like this. So we got these different ones, different members. Okay, so now we have to, there's a couple things I have to, okay, now we have to go into and define the cross sections of these members. Before I do that though, you can see the, there's like a 3D view over here. So you can, there's a 3D renderer that will kind of just, okay, so, and it will ask you to save the changes every once in a while. So we'll just go ahead and save it. Oh, I probably have to give it a name. Test boom. Okay. Okay, so the sections of the block of the balsa wood or whatever are really large. So it's looking like big boards in here. So we need to change that. So we go back to the sections and you can define different sections. So just like you have different sizes of balsa wood that you would use to build your Boomilever and different densities. Well, there's really only 3 densities they let you use for this. You can choose between 3 densities: a medium, a light, a medium, and a heavy density. But you can choose the section size, the cross section size of your Boomilevers or of your balsa wood sticks, and so you define different ones. So so again, you go to the sections part, and then so we'll define different sections. Right now, section 1 is not even defined. So we need to set that up. So let's go to Builder. Builder kind of lets you, what we need to do is we're going to pick under section templates, we're going to pick a rectangular section. I haven't tried any of these others. You might want to try. I mean, in real life, it's probably really hard to get a hollow rectangular balsa wood, but maybe in this software you can do it. I haven't tried that. But we're just going to do a regular solid rectangular cross section. Now the thing is this, then you go over here to the right side and you get to pick what balsa grade you want, light, medium, or heavy. My suggestion is just to stick with light for now. You can try medium and heavy, but I think it'll just make your structures too big or too heavy. So then we go to the dimensions, and these are in millimeters. So that's the only thing that's not going to be in meters is these cross section sizes. So, but normally we get balsa wood in like fractions of an inch, but just for our case, let's just make these, it's not going to be really perfect, but let's just make these 5 millimeters by 5 millimeters cross section. Okay, square cross sections to make it simple. Actually, let's make it I don't know, let's make it 8 by 5 to keep it so we have some difference in size. So we've got 8 millimeters high balsa wood and 3 millimeters wide, and we're using light density balsa wood. So then you submit that, and that will create that section. And you can change the name of the section. Right now it's just called section 1, 8 by 5 here, and it's color coded black. Let's create a new section. Let's maybe say that's all for that section was for all the base pieces, but then for these tension pieces, let's create a different section just to have something different. So let's do rectangular again. And let's say these tension pieces are, I don't know, 4 by 4. They're smaller, 4 millimeters by 4 millimeters square. Okay, so we also want that to be light grade balsa wood, or well, let's just change it to medium because they're under tension or something. So we'll submit that. And that will create 2 sections. Now we have to tell which members are, now that all these members are listed as being section 1, or cross section 1 versus cross section 2 pieces. So, but we want these members 7, 8, you can see members 7, 8, 9, and 10, the tension ones, to be the green cross section ones. So we go back, we go to members, and under members, you can open this data set, the spreadsheet looking thing. And under here, you can see that they all have section ID number 1. But we want these last 7, 8, 9, and 10, those members to be section ID number 2. So we'll change that to number 2, change that to number 2, that to number 2, that to number 2. Okay. So then we apply that. That should change it. Should change the color now. So it should be color coded. Okay, zoom out a little bit. Now let's check for the 3D if it looks right in 3D. So we'll go to the 3D renderer, and that looks a lot kind of like what, the purple ones here are the 4 by 4 millimeters, and the red ones are what, 8 high and 5 wide or something, I think we did. But that's kind of like what it looks like. So basic Boomilever. Okay, so now we have to get set up to do the testing. So actually get back out of the 3D. We have to go to, okay, first of all, we need to turn self-weight on, because self-weight means the weight of the structure itself counts as what needs to be held in addition to the weight that's going to be from the loading block. So the Boomilever needs to hold itself in addition to the loading block. So you have to turn self-weight on. And make sure it's pointing in the minus Y direction, which is downward. Let's see. I think it's turned on. So that's on. Yeah, self-weight is on. So there should be a little blue thing down here that says self-weight is on. Okay, now we need to apply the area. We're applying an area load. So in the area load, it's it has to be you have to set it up to be 2-way, and we're not doing a point load, we're doing area load, and but we need to specify either a triangle or square area. In this case, we're specifying the square area of the loading block. So it'll be 4, 5, 6, 7, but we don't do 4, 5, 6, 7 because that doesn't make, you need to give the numbers as they go, the node numbers as they go around the perimeter of that square. So we have to, the corner node IDs over here on the left will be node 4, then node 6, and node 7, and node 5. That creates that whole area down there, right? So 4, 6, 7, and 5. And then the pressure magnitude, you can just set it to be whatever. But actually, I think it has to be minus to go in the negative direction. You can set it whatever. It'll change that eventually as it's testing it, right? But you just need to give it some initial pressure, which is, you don't need to worry about what it is. Just give it a minus value, and make sure it's on the y-axis. And then you apply. Okay, then you don't need to worry about that. And so that puts essentially a loading block on it. Let's see if there's something else I'm missing. Okay. Okay. So
just a
now
quick
you
note
go.
up, Ram and Emily. I don't have you guys know this. I don't have the long Zoom meeting license, so in about 8 minutes, if we're not done yet, we're just gonna rejoin the same meeting to keep going. Sorry. Can you please, Goorskey?
Yeah, we'll just rejoin right back in. Okay, you can use like the scroll button on your mouse to zoom in and out, or I guess you can use. Oh, That's just a scale thing on the right here. It doesn't really change the numbers. Okay, so then now you want to test it, right? I think, unless I did something wrong, but I think that's it. Then you go to Science Olympiad structures and the add-ons, and then we'd have to test it. For some reason, it's saying we only have 4 solves left. I don't know why it's saying that, because that competition was over, and I can't change it. Anyway, so we'll just do it as if this was a competition. So we'll test the structure. Okay, so then it will give you kind of a result of the test. So the result will give you, it actually, it weighed, our Boomilever that we designed weighed this much, 7.7 grams, right? And it held this much, 13.4 kilograms. So it'll figure out the score for you. So that gives you a score of 1,700. If you held all 15 kilograms, it will actually add the 5,000 bonus to that 15 kilograms to get the score, right? So it'll include that bonus, which is where you want to be. I think in this event, you definitely want to get that bonus. You want to hold just over 15 kilograms. So, okay, so we didn't have any problems, but it does give you some, so here it says we have 3 solves left for some reason, but let's just pretend this is the competition. That's all we have. Okay, so we have it says check the result, the top combined stress Z in member 7. I don't know what all of this means, but I do know how to find out. It's saying something's wrong with number 7, member number 7. The top combined stress Z in member 7. So you can actually go here and you can solve, I think, you can just do you don't have to do the buckling. You just solve the dynamic one, and it will solve it, and it will give you some stuff. So we were talking about stress. It's the top combined Z stress, and yeah, that's what you want to look at here under the stress. You can look at all the torsion and shear and all that stuff. But what it does in member 7, now we got to find member 7. I think member 7 was, member 7 was, okay, I think the red ones are the one, well, let me think. The blue ones are the ones that are okay. The red ones are the ones that failed. If I read this thing correctly, it's kind of hard to see. Oh, and I don't know how to get out of that. Let's see. How do I view all of them? So, okay, well, maybe I'm just viewing one at a time. Let's see. Okay, so that's not member 7. Member 7 is this one. It's hard to see. I can't do this very well. Hang on. Slide this over. Okay, so number 7 is this one. It's one of the tension one, and so it has a negative pressure because it's being pulled apart, and so it broke there. So what you need to do maybe then is thicken up your tension of those beams. And if we have to thicken up that one, we probably have to thicken up the other one, the other tension beams. So what would we do? We would go back to the model up here, and then you go back to sections. So we want to change section 2, right? We want to change the cross section or the density or something. We could change the density, but let's just change the cross section. So we're going to go back to section 2, which was the 4x4. Go back to the builder and change that. And we'll go back to the dimensions and we'll change it. I don't know. Let's just make it, I don't know, say 8x4. See if that helps. Okay. Then obviously that's going to add more, twice as much mass to those beams because they were 4x4 and now they're 8x4. Okay, so then we submit that. The only problem I have with this software really is that it doesn't automatically change the name. It's still saying it's 4x4, so we should probably call it 8x4 now. So we'll apply that. So now the name is 8x4. I mean, in your competition, I don't think you need to worry about that part too much. You just need to get your stuff done fast enough. So, okay, so let's go do it. Let's solve this with a test. No, sorry, not solve this. Let's, well, we could solve it again. But let's just go ahead and do the Science Olympiad test, and let's do another structure. Okay, so now it actually weighed more, but it broke a little bit earlier for some reason. I don't know why. And now it says it broke on number 3, which is one of these points that hold the block. So we would go back in and we'd probably change the section size for, maybe add a different section size for number 3 and number 4. So we would say, okay, this section, go to builder, and then we would go to a rectangle shape. And what would we have? 10, we had 10 by 4, 10 by 5. Let's just make it like, I don't know, extreme, 15 millimeters by 5 millimeters wide. So then you submit, oh, wait, I don't think I did that right. No, I think it's right. Yeah, 15 by 5. Okay, so then we want to make sure that, oh no. We go back to members, and we got to make sure we're going to change 3 and 4 to be this section 3, which is 15 by 5 now. So we go to spreadsheet, we go to members 3 and 4, make those to be section ID number 3, and we apply that, and they should show up as, well, they show up kind of pinkish, and we can see the 3D view of that, and we can see, okay, yeah, they're much taller than the other ones. So, okay, so let's go back and, I don't want to take a picture, go back and solve this thing again or test it with the Science Olympiad test app. Okay, so, okay, we didn't increase the weight that much, but we did increase how much more we held. So we're almost holding all the weight. So our score is low now, but if we held just a little bit more, it would, instead of 15, it would have been like 20, right? Because you would get the 5,000 bonus and you would have been a lot higher score. So now it's saying we got a problem with member 5. So you can go in, you can go into member 5 and change its size and instruction, you know, the cross section. So I think mainly the strategy is to have a simple design that you come up with, and then you change the cross section sizes to optimize your design.
Yeah.
Hope I don't miss our kids' score. They should have already graded those things, but we haven't got the results back from the last tournament. There was like 200 teams there for Division B and 200 for Division C. Okay, so yeah. So I guess what I was trying to say is you probably just want to do get a design that works pretty well, and then you optimize it for a given set of parameters, the parameters being the distance from the testing wall the event supervisor gives you, and the width of these attachment points from the center line. Those are the two things that could change from competition to competition. But so you get one to work for one distance, you know, one set of parameters, and then you keep optimizing the cross section areas. And I think the minimum thickness you can be, you know, the height or width you can do is like 1.5 millimeters. So you can't go super thin, but 1.5 is kind of thin.
Sure.
And then, you know, and then you just work on changing it for different, you know, you can move this whole bloating block, move all these nodes in closer, you know, move them in by 5 or 10 centimeters, and then see if your optimization works. And if you take really good notes on all these tests, you know, you can test unlimited times in practice, supposedly. It doesn't give you only 5 times to test like you get during the competition. So you can test as much as you want, take a bunch of notes on what the best cross-section sizes are for all your different members. You can have it all written out, what your node positions are going to be. And then you can just, you know, fly through that at the competition. And so you can really pay off if you practice hard on this one, I think. And, you know, it's a lot easier than building actual Boomilever's.
Yeah.
And you don't have to worry about like side-to-side motions and the low, you know, all the pouring of the sand and everything that, you know, you might put too much weight on one side versus the other side. You don't have to worry about any of that. So, And the hook attachment point is a perfect attachment point. It's not going to break at the attachment points. So that's kind of nice. But just to do one more thing here, I think we said the last time it was breaking at 5 and 6. So let's just change members 5 and 6 to be the same as members 3 and 4 that we had made taller. So members 5 and 6 will be. So this section ID, you define those cross sections and materials, and those are basically like the type of balsa wood sticks you're using, right? And then then the members, you tell which stick you made it out of, basically, if that makes any sense.
Yeah.
I think once you guys start playing around with it, it took me a while to figure that out. I thought each member had its own section ID, and that's what messed me up. But no, you just need as many section IDs as different kinds of balsa wood that you're using, I guess. Okay, so we can go back, and then we can try to test this thing. We only have one solve left, so this has got to be it. Okay, hey, we held everything. We were a little
Right.
12 grams, which isn't great, but we held everything. So now our score is 1,600. I think we did better in the very beginning when we didn't. But okay. So let's say that was the last one. We would submit. I think you can submit the last test. Oh yeah, when you submit it, you have to tell what. Okay, so I've never seen this before, but when you submit it, you tell which invitational it is. Which one? Oh, and the one that they had was, they said it was the Yale Invitational, but I don't know. I'm not going to submit it to that. Because I don't think there was that. The one we went to was the practice one, but it's not listed in here. So anyway, they said to submit it to Yale. And okay, I can't submit it because anyway, for some reason I can't submit it. Okay, I don't want to submit it anyway. Okay, but yeah, so you can get pretty high scores. I mean, I was reading on the forums where people said, oh, they got 7,000 points, or they got several people got over 4,000. I think getting 4,000 is really possible. I don't know about 7,000. That seems kind of impossible. And I don't know if there, in the regular Boomilever, there used to be a minimum weight, and I don't think there is. So maybe you can get a really high score, but it seems kind of, I think 4,000 is pretty doable. Argo's got over 3,000 last time, but their distance from the testing wall, I think, was like 30 or 35 centimeters. So that's easier, than we had in real Boomilever. So it was a good score, but it probably wasn't the best score. We don't know yet.
Sure.
Yeah. So I don't know. Do you guys have any questions? You can see the 3D view and all that. And you can go to the nodes. You can look on the spreadsheets. You can get those numbers and put them in your own spreadsheets in your notes and stuff, so you can keep track of what all the positions are. So we could just shift everything longer or shorter. So we could do this. We could do that 0.3, 0.3 for a Boomilever that had to be 30 centimeters from the testing wall. Just shift that, right? Our design, that's the only things you would have to do, and everything would shift in closer, right? You wouldn't have to do anything else. But if you made a more complicated one with the, cross with the, X braces and things like that, you would have to change those positions accordingly. And, maybe you can set up something on your calculator or something to do those calculations sort of automatically. I don't know. Because I don't think I think they let you use calculator and stuff. I'm not sure how they could stop you from using calculator anyways, but yeah, I think you should have to use calculator, because if you have to calculate, like using some trigonometry, the positions of the nodes for cross braces or something, you need to be able to calculate those, because you don't know what the distance from you don't know the distance the loading block is from the testing wall till you get there to the competition. So you still have to calculate something maybe. But this is just a really simple design. That you can just certainly not an optimal design, I don't think, but like I said, you want to adjust the cross sections. You probably want to start with the just light balsa wood, because I think heavy balsa wood is going to end up being too heavy. But that's up to you guys, I guess. Is there any more questions, or you want me to do anything in here in SkyCiv to see what happens, or?
I had an idea about, I thought about how to find the positions for the nodes to place the cross braces. There's an option to split up the members into multiple smaller members instead of one large member.
Oh, how do you do that? Let me get out of 3D here.
I remember seeing it in the tutorial. Not really sure. I think you'd right click or something.
Oh yeah, possibly. Yeah, if you right click, you can add
yeah, split member. Is that it?
Split member. Okay, split members. Let's see.
Yeah, so divide member into equal parts.
Okay, so this member is from node 2 to node 4. That's the member it is right now. And divide member into equal parts. So we could divide it. Oh, okay, here you go. So yeah, divide by, let's say, 4 parts. Yeah, and then it creates members for you. So we could do the same thing here. Okay, that's a good thing.
So that would make cross bracing a lot easier.
Yeah. Okay, we could try that. I don't think I'll be able to test it, but yeah, and then you can just add in more members like this. You know, and each time you can then go in and define what the members which section ID you have. Usually cross braces are really thin, so you might need to create a new cross section for. Ooh. Okay, I didn't realize that. That's pretty good. So if we go back in sections and we create a new section that's like really small, let's say, I don't know. Well, I think the minimum was 1.5 by 1.5. Yeah, let's keep it light density. Okay. Submit.
Hey, Rom. Next, dude.
Yeah, I didn't even know this. Okay, so if we go back to members, then we have to tell what members. We're starting with 17 going up to the 23 or something. So all these members are going to be section ID 4. Oh, not 5, 4. Okay, that's useful. Well, let's see. I haven't played around with cross sections at all. I mean, with the having sections at all. I mean, not sections, braces. I haven't tried anything with braces. Okay, so these are showing up as, you can still do a solved model. I just don't think I can do I can't. How's it get? It says submit score. I don't know what happened there. Okay, so it won't let me solve that, but I can still do a solve here. And that can, so it looks like you can do this static analysis stuff and figure out. So actually everything's showing up blue, so it holds everything. Oh, okay. Yeah, so I don't know. Yeah, that's something to think about. That's good. And then you can look at the 3D view. So now it's actually starting to look really like the Boomileavers we used to build. Okay, well that's neat. I just need to figure out how to get this add-on thing working. All right. Do you guys have any other questions or anything you want to look at in here while I'm in here, or?
I can't tell you how grateful I am that you spent the time to show us this. Thank you so much, David. Yeah,
this one is really just, you got to get on there and practice. And then I think when in the competition, just one person will be building and the other person just kind of helping out. I don't think you can both, I'm not sure if you both can be in there at the same time, but.
Well,
okay, I'm just going to save that. Yeah.
It's an incredible tool. I mean, this is a really, really cool software.
Yeah, I think this could be really useful for when we actually really are building things in real life. You can
Yeah.
actually do this first a few times and get some good designs, and then go, at least this will kind of narrow it down for you, get you in the ballpark of what kind of balsa wood you need. And you can do a lot more. Like, you can add other things, and like, this is kind of an ideal case where you just have a perfect block just pushing down, straight down, no side forces. You don't have to worry about attaching to the hook and all that. But with like bridges, or you don't really have to worry about attaching things. So that's what makes Boomilevers hard, is attaching to the hook. But yeah, okay. I'll go ahead and stop sharing unless there's something else anybody wants to see.